Welcome to part 1 of Competency 10. This competency is in Domain 2, which is 33% of your exam. In this video, we will answer questions relating to limits and continuity. Okay, number 1. What is the limit of case of x equals 9x minus x to the third as x approaches negative 1? Okay, well, basically, what we need to do for these as we discuss them is graph them. So you need your y equals, and then, okay, let's clear that out. That isn't quite what we needed. Okay, we need 9x minus x caret up and third. Okay, double check that it's okay. Now let's push enter. Always like to push enter and make sure I have everything in. Okay, now we can graph it. Okay, so we can do one thing first. You have two options here. You can push trace, and we're saying -1. When you have it on trace and you see that flashing, put in the value that you're approaching. Okay, so that's -1. So -1, enter. Okay, now look at what it does for us. It automatically says -8. So there we go. Now let's go to second graph. That gets us our table. Scoot over and it says again -8. So you always need to remember there are two ways to go with this. And that's very evident in the next one. So let's read number 2. What is the limit of h of x equals 3 sine 2x plus as x approaches pi over 4? Okay, so let's go back to our y equals. Okay, let's clear that out. 3 sine 2x. Okay, I'm going to push enter. All right, we can, okay, good. It's graphing good. Now, if yours is a straight line and it looks like it might be trying to work or it looks odd, this is what you need to do. Go to mode and go down and make sure you're on radians, okay? If you are not on radians, your trig won't work, okay, automatically. Okay, so we'll go back and we'll graph. Now, let's say that, let's say before you even do that, okay, I didn't know how to word it, what I want to say, but this is another option. Okay, let's go back and this is the best way for me to show you. Let's just do this. Let's go over and put it in degrees. Let's graph. Oops, that looks silly. Okay. Don't do other things. There's lots of suggestions online. We could do this. We could say zoom. See that number 7? Try it. And there you go. Okay. Now notice the picture was a little different if you changed your mode. But we don't have to change the mode because we have the 7 trig zoom. Okay. All right. So now what do? We say trace. Okay. And we need to actually put in power of 4 like we did for the -1. Okay, let's try it. Second caret up, divide by 4, enter. Okay. All right. They're saying that's a little dicey. I don't agree with that. Nope. So this one doesn't always work like that. So as we go up and we get closer and closer, let's change our mode. I'm not liking the way that looks. Let's go back to our radian. If things don't work, let's graph. Oh my goodness. We need zoom 6. There we go. Back. It was on zoom 7. Okay. So I'm thinking that we're looking at B. Okay. I'm going to push my trace and then second caret up, divide by 4. Okay. I'm going to push enter. There it is. Now see, that's not always a good idea. Okay. The best idea for this would go straight to your table. Second graph. Okay. And we need to look, see, that's another thing. See how it's kind of difficult to go, see how it skips our 3. It's going up, it's going down, and we could go to second window. Okay, we're here at -1. I'm going to put it back on 1 because actually pi over 4 is getting close to 1 a little bit. Actually, it's close to 3/4. Okay. All right. Now, this is what I'm going to do. See where it says table value? That's what that is, table value. I'm going to push 0.01. Okay. Now let's go to our table and see if it helps us. Nah, I'm not feeling it. Let's go to our 0.7. It is getting closer to 3. 0.75-ish. There, yes. And evaluate it. See, close to 3/4. Okay, but probably for this one, noticing that you either have pi over 2 or pi over 3 or integers, your best situation would be to, you could also simply put in pi and try that too. Okay, I mean pi over 4. Watch this. Let's clear out of all this. The best way for that one was tracing. I know you kind of have to know what you're looking for and understand uh, all the properties. Okay, so let's do 3 sine. Notice we're in a regular window. No, we're not graphing anything. We don't want y equals just your home page. Okay, 3 sine 2 times the second, caret up for your pi, divide by 4, close your parentheses, and you get 3. So the value is 3. The limit does exist. And as you get close to pi over 4, that's what you're going to get. And when you trace, that gives you the value. So that tells us that B is what we need. Okay. All right. Now let's look at number 3. If m of x equals x minus 1 over x squared plus x plus 3, what is the limit of m of x as x approaches 3? Okay. All right. This is what we need to do. You can plug in the value for 3. But let's go to our y equals, clear that out. Now this is a rational function. So I need to put this in as a rational and you'll see why, okay? All right. So I need alpha window and I'm going to go over to number 1. Now I'm going to put in my function as I see it written, okay? X minus 1, arrow down. And we have x, square it, okay, plus the x plus the 3. Double check that we have it entered correctly. Okay, now let's graph it. Okay, that is the correct graph. It looks unusual, but it is accurate. What I want to do is second graph to get the table. Oh, we need to reset our table set. So go second window. See where it says the blue table set up there? That reminds you what you need to push. Okay, what do we need to do here? All right, I'm going to say 3 is where we want to end up first. And then here, I'm looking at our answer choices. There's a lot of fractions going on here. Okay. But I'm just going to set it at 1. Okay, and I'm going to go back to second table. And there it is. Because we set up our original rational function correctly in that format, okay, and not with parentheses, then our answers end up in the format. So then we can just put our x values in 1. You are honestly going to have to play with this, okay? But we see right now that 2 over 15 is our correct answer. Now, there are ways to, yes, I agree. You can do all this by hand. You can just plug 3 into your rational function as is, and you will come out with 2 over 15. Okay. But this is a nice, accurate way to check that. Okay. And it's very quick if practice with it and get used to it. Okay. That being said, let's try number 4. Now, number 4, I believe, is just a little different. Couple ways to deal with number 4. I used a derivative method the first time. I'm not going to show you that. Let's see. It says if n of x, okay, in a rational function, what is the limit of n of x as x approaches -2? Okay, and this is what we need to do. All right, we're going to second mode, get out of that, okay? Go back to our y equals. We can go ahead and just put in our rational on top of what we have. So minus 3x minus 6. Okay, let's go down. Then we have x to the third. See, and I'm going to arrow over and just plug a 3 in over that. And then it's plus 8, right? So I can actually delete out, and go over and put in an 8, okay? Or you can clear it all out, start fresh, okay? All right, I'm going to graph it. Okay, that is an accurate graph. I'm believing that. Now let's do a trace. I'm going to say trace, and I'm going to go to the -2, okay? Minus 2. Push enter. And see what it's doing. It's not giving us a value. So now I'm going to say second graph. Okay, we want -2. I'm going to go to -2. Let's see what happens. There's a hole literally in our graph. It is discontinuous at -2. So we need to figure out, what are we getting near? Okay. Well, I can see right now that we're not near that half. Okay. Let's go to decimals. Let's see. Let's say second window to do our table set. I'm going to put it at -2, and we can go up and down around that. And then what I want to do is get as close to -2 as I can, but I need a decimal to do that. Okay, so let's see if we can change it to decimals. So 0.01. Okay, and I'm doing 0.01 because I want 2 decimals, uh, 2 places past the decimal, 2 digits beyond the decimal. Okay. So now I'm going to go second graph. And okay, now this gets me somewhere. Now I'm on my decimals. When I go above my -2, my -2, I'm getting close to, see where it says error. Here, let me arrow over. I highlighted it. That's close to negative. Okay, so now we know we need negative. A and C are out. They're positive. And above it, very close to 0.25, which is a 4. Go below my error, okay? That is also very close to negative 0.25. Therefore, I know that my limit is at -1/4. So D is out, okay? You're literally estimating. Now, there are other ways to do it where we factor out, which, it depends on how good you are at the factoring. Okay, and you might be great. There are days I have trouble seeing it if I'm getting super tired and the numbers are a little dicey. Okay, now notice when I pull out the -3, I get x plus 2, but you may not automatically know that this factors in this manner. Okay, x squared minus 2x plus 4. I wouldn't try that. I mean, I know it's good. You factor and then you plug in your minus 2. You can work it out. I'm not going to do that, but you can. And yes, you'll end up with this. You will end up with minus 3. And then 12. Yes, it'll be 12. And that it will give you the negative 1 here and 4 here. Okay? But your calculator actually will be very accurate, and we did find a good way to get that, okay, or numerically. Number 5, what is the value of the limit as x approaches infinity for the function 3x to the 5th minus 10x to the 3rd plus 40? So what they're asking is, as the x gets larger and larger, infinitely large, what happens? What is the limit? Okay, the best way to look at this function is to analyze each term. Well, we kind of can't do that till we factor, which often when we're looking at values of limits, we must do some factoring. Okay, always look to see if you can factor. Well, let's factor out this leading term of x to the 5th. Okay, so what do we have left behind? We have 3 minus 10x to the 3rd over x to the 5th plus 40 over x to the 5th. Okay, so that's how I'm going to look at it as far as factoring out. Same thing as dividing it out. Okay, so now let's keep analyzing what really is going to happen. Well, not exactly going to analyze it. I'm going to clean it up first before I analyze. So to the 5th. So now I have 3. That's let me write this a little bit better. As I've said, I'm not the best with this pen, but at least I get my point across. So I have x to the 5th in parentheses 3 minus, okay, we're going to use the laws of exponents, and that gives me x squared in the denominator. 3 minus 5 is a negative 2, which means my x squared must stay in the denominator. Then, of course, we aren't going to do anything with 40 over x to the 5th. Okay, now we can analyze. And this implication is that I have x to the 5 and then 3. Now, 10 we're going to subtract 10 over x squared. Well, x approaching infinitely large values of x, and then you square it. This means that that term has to approach 0. So that limit is minus 0. And the same thing for the next one. It's going to approach pretty quickly, okay? Because it's x to the 5th, so it's going to approach 0 even faster. So then when we simplify that, clean that up, we see that we have 3x to the 5th. And as x approaches infinitely large unknown amounts, it is going to have an infinite boundary. I mean, it has no boundary. But we do say, even though it has no boundary, for this function, we can say that it is going to approach plus infinity, which gives us, we know it's not going to approach 0 because we factored out and proved this. And we know the limit exists. When we factored it, we started seeing that. So it's not going to be negative infinity. It's going to be positive infinity because the given says as x approaches infinity. Okay, before we went on, I wanted to take a moment to talk about the rules of limits. And now this is, let's say, infinite limits, okay? As x approaches infinity. And the notation, this means that you have p of x, for p of x to the n of q of x to the m, that's just your rational situation. And if that's your function and this is your degree, n or m, okay? So if n is less than m, we have a 0 limit. Your limit is 0. If n and m are equal, then we know that we can just take those leading coefficients because m and n are your leading exponents, okay? Your leading degrees. Okay, then for the situation where n is greater than m, we have that the limit does not exist, okay? Thought I'd just make a point of that. If you want to, here, let me clean it up and you can take a screenshot if you want. If you like, for future reference. Of course, you can find this anywhere on the internet, okay? But that's what we're going to kind of refer back to this as we move on. Okay. All right. Okay, number 6. What is the value of the limit? And this is as x goes to infinity. Okay, they give you your rational function. Well, we've noticed that our degrees are equal. Our n and m are equal. So in this case, this implies that we can take these leading co-ops. Okay, now let's see. There it is. These two leading coefficients and bring them out. So we have negative 3 over 6, which equals negative 1 over 2. Okay? All right, so we know A is the appropriate option. All right? Now, if you don't remember these things, you can graph it, take a look at it, and there are other ways to get to that point and using your answer options. Okay, now we have number 7. What is the value of the limit of x as x approaches negative infinity? Okay, again, we have these leading coefficients. Well, n is less than m, okay? And that was a situation where your limit had equals 0. However, for this one, let's go ahead and put this in our calculator and see what we come up with. So let's go back to our y equals, clear this out. You remember how to put in a fraction? Alpha, alpha, there it is, window, an arrow over. We want number 1, it's highlighted. Okay, now let's just put all that in. 10x, carrot up to the third, arrow over, plus 5. Now arrow down, and we have 8x, carrot up, 5. Okay, and we arrow over, plus x, plus 9. Okay, double check my numbers, make sure that they're correct. Okay, now let's graph it. Okay, zoom 6. See, I had to change my zoom, my window. Okay, the limit to infinity approaches 0. All right, let me check my mode. Okay, I'm going to make sure I'm on real numbers. Enter, graph it again. Okay, let's try zoom. I tried zoom 6, so let's zoom in. And you have to press enter twice. Okay, that's what I want to see. Okay. Yes. Looks like as we go to infinity, this part right here, that's not what we're looking at. We're looking as it goes infinitely. So let me zoom back out. Okay. That's number 3. And you have to push enter twice. Now see how it goes along 0? as we move away, either way, to infinity. So D is the correct option. I know it's very tricky. You want to look at what's happening here near the origin, and we're not. We're looking at what happens as we go away from the origin, okay? All right, and we're in particular looking at what? They said minus infinity. So you're looking at what happens as you go to the left, okay? All right. So let's move on to number 8. What is the value of the limit here as x approaches infinity? Okay, so what do we need to do? Well, first off, let's look here. Our leading exponentials here are degrees. So I'm seeing that n is greater than m. In this case, the limit does not exist. However, we could put that in the calculator and just see what happens, okay? So second mode, I'm going to go back to that, and I'm going to clear the whole thing. Well, I can just clear the top, and then I can go to the bottom, and let's clear the bottom. Okay, now let's put it in fresh. Okay, negative 9, x up to the 6. So x caret up 6. You have to arrow over minus the 5x plus 2. Okay, and go down. I was double checking my numbers. Okay, 10x caret up to the 4, arrow over, and it is minus 3. Subtract 3. Oh, but 3x. Yes, 3x. Okay, double check my numbers. Okay, now, all right, let's graph that. Ooh, okay. Yes, definitely. The limit does not exist. I see a lot of things going on. Let's go second graph. Second graph. So I can get the table. And we can reset second window table set. Let's get this back to, let's try 1. And let's go to 0. Okay. All right. Second graph. Oh, see, there's all the errors I was looking for. See that? Okay, so it's giving us, but it doesn't exist because other than that, it looks like we have an infinite, unbounded situation. So the limit does not exist. I would have to agree that with that. Looks like we have a lot going on. Let's look at the graph again. Yeah, definitely. Okay, so I would say that is a correct solution. Okay. Now let's look at number 9. Okay, they give us the same type of rational function. Then they want to know something totally different. Okay, if then x is not for which values? They want us to look at the values where it's discontinuous. Then h of x is not continuous for which x values. Okay, and they give us some options. All right, so let's put that in. I think graphing it is the way to go for this one again. So let's go to the top, clear it out. Arrow down to the bottom, clear it out. Right, go back up. So we have x plus 4, and I arrow down 3x, and I can just do square on that one, and it automatically goes over for me. And then I say plus 26x, and that is right. And then I say subtract 9. Okay, let's graph that. Oh, goodness, goodness, goodness. Yeah. I am looking at probably, let's look at our options we've got. Look at our graph. I'm looking at a positive fraction somewhere between 0 and 1 right here in that area. So your fraction should not be negative. So B is out. And then the whole number, the integer, was not negative. Looks like we have a whole number that could be the 9. It's not the 3 because 3's right here. I'm thinking that we have a positive fraction and then a negative integer. So this is a positive integer. That's not going to work. Okay. I really don't think negative 3 would be right here. 1, 2, 3. That's not discontinuous. I mean, it's not. It's continuous. Okay. We're looking for not continuous. So I would say A would be the choice. But the best way to really verify this is go to your table. Second graph. Okay. And I'm going to go to, well, I don't have my X set up for fractions. I have my X values set up for integers. So let's go second table, and I'm going to say -9. Okay. Then I'm going to go back to my table. I mean, second table, second window. Okay. And it does have an error at -9. So that's not continuous at -9. I know 100%. So now I am going to go second window. Now I want to go to 1/3. Okay. So I'm going to say 1 divided by 3. Okay. However, you know what? Let's go ahead and try it. Going with whole numbers, I don't know. I don't think it's going to work. Let's go ahead and look and see if it does. It does work. Voila, we have it. So we didn't have to mess with anything else. Great. Showed us right off. So A is the option. That's where it's discontinuous. Okay. All right. Now, 10. If this limit, okay, this is algebra. Okay. If the limit of x as it approaches 2 for the function x to the third plus kx plus 8 equals 6. Okay, what is the value of k? This is an algebraic thing, and we can show it on the calculator once we deal with our algebra, okay? All right, so what we're going to do is the number 2 will go in for x, okay? All right, so what we will have is we're going to say this implies that 8, oh, that is value is going to be 8. 2 to the third. Let's do 2 to the third. 2 to the third plus k times 2 plus 8 equals 6. Now we just simply solve it algebraically, okay? So what do we have? We have 2k plus 2 to the third power is 8. 8 plus 8 equals 6. 2k plus, all right, let me scoot that over just a little, and I miswrote anyway. 2k plus 16 equals 6. Subtract 16 from both sides. Okay? Cancels out. 2k equals minus 10. Divide by 2 on both sides. And what do we have? -5. K equals -5. All right? But this is what I need you to do. All right. If we put in, if we call kx, say if we say k equals x, we can just put this into the calculator, all right? Or even a better option, now that we see the -5, okay, put that -5 in for the k, just to double check it. Okay, actually into this. Okay. All right. We're not, and then we'll go to where 2 is and check the 6. Let me show you. I think I'm being too confusing, too cryptic. Okay. Let's go here, clear every single thing out. All right. So what do we need? We need x, caret up to the third, arrow over. So now instead of having plus k, we're going to have -5. minus 5x plus 8, and I entered it correctly. Now don't do the equals thing. That's if you push, there is no equal, you push enter, it's all going to go away. So now we just simply graph, see what we have. Okay, all right. Oh, and our color changed. Ooh, let's go over and change that color. Let's push enter and let's make this magenta. Enter. Okay, now let's graph it. Okay, we can see it. So now if we go to 2, as x approaches 2, go to 1, 2, 2, saying -5. Let's go to our graph. Hmm. Let's push 2 and 1. Now we should be somewhere. And it does equal 6. When x is 2, it does equal 6. So let's go back to our graph. That was hard to, 1, 2. It's kind of hard to, oh, let's trace. Use trace. And we can go to 2. Let's see if it does it. Nope. Well, let's enter 2 while we're on trace. Well, that didn't work either. Let's go trace. 2. Enter. Yes, now there it is. 2 and 6. Perfect. So we know that if k is -5, this equation at 2 does have the limit, does equal 6, okay, as x approaches 2. Perfect. Okay. All right. That is the last question in this first video. I want to thank you so much for watching the videos and for all those people who subscribed. And it's been great. People are starting to share more. I've noticed a lot of likes. That's great. We really, really appreciate it. And I hope this is helping you. We're going to keep on working till we get all the competencies up. And oh, thank you again for subscribing and happy testing.